Welcome to Check Your Understanding 10.1a. Let's talk about some goldfish. Your teacher brings 2 bags of colored goldfish crackers to class. Bag 1 has 25% red crackers, and we're going to call that P1 in red. How nice. And bag 2 has 35% red crackers. Oh, and green, but different. Each bag contains more than 1,000 crackers. Using a paper cup, your teacher takes a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 crackers from bag 2. Let P1 hat minus P2 hat be the difference in sample proportions of red crackers. What is the shape of the sampling distribution of P1 hat minus P2 hat? Why? Now think about that sampling distribution. All possible samples of size 50 from P1, P2, those proportion that are red, subtract them, plot them on a graph. So the shape, we would like it to be approximately normal, but you need to check the large counts condition in order for that sampling distribution to be approximately normal. And what's different on this one, as opposed to just back when we did sampling distribution of P hat, is you just have to check large counts for both. So no problem. We have the bag 1 where we're taking a sample of 50. And because it has 25% red, we would expect 12.5 of them to be red and 37.5 of them to not be red. That's okay that those aren't whole numbers. We just care that it's more than 10. In the bag 2, we take a sample of 40 and we expect 14 to be red and 26 to not be red. All those numbers are greater than 10. So it passes that large counts condition, and the sampling distribution will be approximately normal. Super. Next, find the mean of the sampling distribution. So we know when we find the mean of the difference of 2 random variables, we can just subtract the means from those 2 different distributions. So the mean of the sampling distribution for P hat of the samples you take from the one where it's 25% red would be 25%, 0.25, and then the other one, 35%. So the mean difference is negative 0.10. And that's fine, that's negative. That's telling us that on average, P1 hat is smaller. This number must be bigger on average. Calculate and interpret the standard deviation. So we know one does not simply add standard deviations. We need to add the variances and take the square root. So here are the variances, or this is a formula you can look at. That's the variance of P1 hat, variance of P2 hat, and then square rooted. And you should get 0.097. It doesn't, okay, yeah, let's go with that. The difference in sample proportion typically varies by about 0.097 from the true difference in proportions of negative 0.10.